Okay, so in the last video, there's one glaring mistake I made. And that is, I didn't have you guys add a true on-off switch. Sometimes you want one, okay? In fact, most of the time you want one, especially for like lights that are on the ceiling. Even if you get it super, super dim, which is great, might you want to actually turn them off? Yeah, okay? So I'm going to show you how to do this. It's very simple. We're going to go in and add a part, so you can click Add Part. And then the part I'm going to clear this here. We're going to scroll down to the Molex connectors, which is con-Molex. Actually, I need to scroll up, so because I was down. There we go, con-Molex. So it's con-Molex, and we're going to pick the very, very first one. Okay. And then what we're going to do is we're going to click the value function. So we went to con-Molex, pick the very first one, and now we're doing the value function, clicking here. And then we're going to change this thing's name, or this value. I'm just going to change it to switch. Okay, you could do SW for short if you want. And then I'm going to show you how we're going to make a power switch out of it. Power switches are really simple ideas. Basically, they're a switch that makes things connect and disconnect to power, and that's it. And so the simplest way for us to do that is, do you see how pin 1 here goes to power? Well, what if it didn't go to power? What if I deleted that there? And so this should still be wired to power here. And then I made it go through the switch. So the switch, so this was my pin 1 before that went directly to power, but now I'm going to make it go through the switch. So it has to connect to here, and then the switch has to connect to power to turn it on. Okay. And so all this is 2 holes on the board where we can wire in a switch. A bunch of different kinds of switches will work. And the reason why we're using 2 holes and not like some fixed switch is that gives us a lot of choices around the kind of switch we'll be able to build with. Bigger switches, smaller switches, rocker switches, slide switches, we can all just wire them into this system. So we'll be able to make a decision on what kind of switch we want to use and just wire it to that spot. Shoot, I have key switches where you put in a key and you turn it to turn stuff on. There's all sorts of different ones. Okay. So that's all you need to do. Go into Add Part, go to con-Molex, go to 2-pin, and then wire it as you see here. All right, so let's talk about how this is going to affect our circuit board. We're going to need to leave an empty space for the switch to go where there's no circuit board inside our case. So last time we talked about the different sizes that things could be. Whoops, I meant to do this. And here we have an example of the medium size enclosure and what the circuit board would look like. Now, if I were to do a single color, like I was just having one zone, can you guys hear me? Okay, because the microphone can hear you. Okay, so I need you to pause. You're gonna cut it in half. If you're one color, you're gonna cut it in half. Which direction you cut it in half, I would recommend taking the longer length and cutting it in half. And the way to do that is to just right click on that longer end, go to Properties, and which number is the biggest here on my sizes? 80 or 50? Not all at once. 80 or 50? It's 80, right? So I'm going to cut that in half. And if I'm doing one color, I can deal with that size, because then I'll leave space for the switch. However, that's if you're doing one color. Just cut the longest edge in half. Okay, right click on that edge, cut the bigger numbers in half, okay, to make it work. If you're doing RGB or RGBW, you have a bigger challenge. If you're going to have a switch and red, green, blue, white controls, how many controls do you have? You have 5, which means you need to split the size of your circuit board into 5 sections, including one empty section. And so I recommend, just for making it so much simpler, go ahead and use the large size case if you're going RGBW plus switch. Okay, make it so much simpler. Because what is 10 centimeters divided by 5? What is 10 centimeters divided by 5? 2. 20 centimeters, 2 centimeters, 20 millimeters. Okay. In my case, I'm doing RGB with a switch, so that's 4. So I'm going to take my 80, my long dimension, I'm going to divide by 4, that's which is 20. And that's what I'm going to build inside. I'm going to build inside that little strip, because then, because I have multiple colors, once I build that strip, I'm going to show you how you can copy the entire board over and build another section and have them all connect together. Rather than having to do this where you have all of these parts and you have to figure out which one goes where, you just solve it for a small section and every other one repeats after that. Okay, so the first thing you're going to do is you're going to put in your potentiometer. And I highly recommend centering it. So this one would be 10, and what would the other direction be, 25? To center it. Okay. And then I'm going to place my connector up here, up top. I'll center that as well. Just 10. We'll call that 45 just for good measure. Okay. And then find a place to put your chip and pay attention to how it's connected to things. Okay, so I'm gonna wire that in there. Looks like, yeah, maybe this way would be good. Okay. And then I'm gonna, piece by piece, find ways to wire this in. Okay. What can be super helpful in this process is what we did with our driver, which is to click polygon and create a polygon. So I'm going to walk you through this. So if I click polygon and go right angle and go hatched, all of those, polygon, right angle, hatch, and then I go around here and call this thing AG&D for the ground. Okay. And then do the same thing on the blue, where I go around and here I'm going to pay attention to what I called my power, what I call my power up here. It's called, I haven't named it yet, so it's just called N money and sign 7. All right. Thought I had labeled it. N money sign 7. Okay. Because up here I have my plus V, and my plus, you can see my ground is on this side, it's called AG&D. And over there is my plus V, and it's called N money sign 7. Yeah, whatever, that's what I called it. So if yours says plus 12V or whatever, we hit rat's nest, and then that's going to help me as I push all these other parts in. Okay. Okay. It feels like I did the wrong thickness here, though. I believe this should be 0.3. Let me show just the top layer right now. Yeah, that's right. Okay, I'll go back to that again. I'm gonna do this one time. You guys pause, because I do want to say this again. For the sake of the video, when you do your polygon, we're doing whatever layer, that angle, but then the width should be 0.3. This looks a little thin, so 0.3 millimeters should be your width. Okay, I'm gonna pause it there. You can go ahead and catch up to where I'm at. Okay, so so the polygon's fine of being right angle 0.3, but what I realized, I was getting confused here, because I was like, hey, why does it not say plus 9 or plus 12 or whatever I made? And that's because that's going to our switch, but on the other side of the switch, That's where it says +9. So you should find whatever yours is called. Mine was called +9. Is yours called +12? And that's what you should name your second polygon. So +9 for me is what I should have called it. So that's just a correction. Apologize for the error. Okay, so once you've done this and you've dragged in your parts and made it as neat as possible, one way you can tell you've done it correctly is my ground goes through this pin 1 on my chip, and pin 4 and pin 8 should have the other pad going through it that says +9V for me. It might say +12V for you, or whatever you put. Okay? And then at this point, what I would do is go ahead and hide your top and bottom layers. In fact, hide everything except for the pads and vias, the unrouted, the dimension. Okay? And this will give you a clear view on what still needs to be routed. And what I'm going to highly, highly recommend, can you guys have your attention? This is a low power circuit. It doesn't need really thick traces. So we're going to use 0.6 millimeters or 24 mils. So that's what we're going to use, not super thick. But I recommend that you don't put them all on the same layer, because we have polygons for +9V on one and a polygon for ground on the other. If I do everything on one layer, I might cut off ground from ground. But if I mix and match, so I do some on one and some on the other, then I leave more space for the ground and +9 volts to get to where it needs to go. So I'll show you that really quickly here. Okay, so the way I like to do it is I'll start with 1. I need to be at 0.6. There we go. And as I wire, do you guys notice what happens here? The grid comes up. And there's a couple of changes I'm going to make. First, I'm going to not do right angle. I'm going to do the one underneath it. Okay. And the second thing I do, if you do rip up and you click on the edge of the polygon, if you find it, there we go. The polygon's still there. You can still see the outline, but now it's easier to see where I'm wiring. And so I'm going to pick some simple wires to wire up on the red layer. And my goal while doing this here is to not pick all of them, but to pick the ones that are kind of like easy to work with here. And if they're a little bit more challenging, I'm going to leave them for the other layer. Okay, so I picked a bunch of short, easy ones. Now I'm going to switch to the bottom layer. I'm going to go ahead and hide the top layer so I don't need to see it. Do the same strategy of ripping up the polygon. There it is. And then I'm going to wire up these slightly more challenging ones. Let's go to there. To there, and then this one looks like it's going to go all the way around. Oops. Okay, I'm going to hit rat's nest here at the end, and then in order to check, I'm going to go up to Tools, DRC. Remember that our clearances all need to be what number? I think I did this in the last video. What number do they need to be? They all need to be 12s. Okay, and you don't need to do this part unless it creates some issues here. But I'm going to check it. It says no errors. And if you're single color, there's only one thing that you need to do. And a bunch of you in your grades previous to this, you didn't do this step. So I'm going to, this is for not just this one, but if you want to improve your grade on a past one, I want you guys to pay attention right now. Okay? So the last step, once it's like, oh, all the errors are done, that means it's electronically going to work. But that doesn't mean when you get it, you'll know how to build it, because you haven't gone through the steps of making sure the silk screen looks right. So to do that, the only layers we need to see now are pads, vias, the edge, the dimension, top place, T place, and T values. I also turn on T origins because sometimes I need to do something, okay? Which actually reminds me right now, how in the world did I not flip my potentiometer over? Thought I already did that. Well, I will have to, I talked about flipping it over, didn't I? In the video? Oh, well then I'll have to reroute my wires and fix that, but yeah, I'm so sorry for missing that detail. The potentiometer has to be on the back. Thought for sure I would have said that, but whatever. But then the next thing is all this text has to line up. So this text that says 1N, it's like, it's for here, but it's like right there. So I'm gonna move it. So it's there, and this one, there. Your part values might be different than mine because of your prototype, and that's okay. I'm gonna move that up here. This is the switch, that's off the board. I'm gonna move it right there, okay? Okay.
There's a via overlapping.
Okay, I'll get to that. So, because I made a mistake here, I'm gonna have to switch these around, but it's gonna be pretty easy to switch once I do that. So yeah, I mean I'll do that. If you're in that position, all you have to do is show those layers, do the rip up function, and we're gonna go ahead and rip up these things that I messed up.
So all controls have to be on one layer and the other.
And then rewire them. Oops. Okay, and then it's all done again. Okay. And then the very last step, when this gets manufactured, what should it have on it? Your name. Okay? Your name. And so to do that, you're going to put in the text. You're going to type in your name, what it is. This is a PWM dimmer version 1.0. Can we put it in the red layer? No, because that's metal. We're going to put it on the T-place layer. That's silkscreen. And then to just double check, I'll just turn that all off and make sure I'm only showing what's going to print, which is I'm going to see the metal pads. I'm going to see the cut of the outline, and I'm going to see T-place and T-values. And that's my circuit board. That's what it's going to look like. Okay? So I'm going to pause the video here, take some questions. And then I'm going to show you, if you're doing RGB or RGBW, what you do to take this file and import it again and again to make more color zones, okay? Okay, so if you're doing more than one zone or more than one color, we're going to need to import this board into itself. So to do that, first I need to make sure I've saved the work I have right now, and then I'm just going to go up and go File, Save As. Okay. And then I'm going to call this one like my final, or maybe my RGB, or something different. GB. Okay. So now I've got two files, and I'm going to import the one I just saved into this one. So because I have two identical files, but to help you set it up so it does a good job, know the width of this or the height, whichever way you're going. If you're stacking height-wise, you would need to know the height. But most of us are stacking width-wise, so we're going to stack a control left and right. So I need to know my width. And in my case, my width is 20 millimeters. I can right-click here and go to Properties and see that, yeah, it goes from 0 to 20 on the X, so that's 20 millimeters. And so I'm going to click this grid, and I'm going to make my grid 20 millimeters so that anything I put in goes in 20 millimeters chunks, so I can know I can line up this and then line up the next thing 20 millimeters and line up the next thing and so on. So I'm going to go then click File and then Import. And it just says Eagle Drawing. File, Import, Eagle Drawing. I'm going to go find that original one, the first one that I saved, which I believe was this. Okay. Wow, did that All right, now, do you see how it's like chunking around on me? But look how it perfectly lines up. You guys see that? Okay. And then it's gonna ask me, well, how do you want to connect all these things? Well, the only things we want to be connected are the power and ground, because they're gonna share that. So do you see the plus 9V and the AG&D? Well, those are named the same thing because they're shared. Everything else is some other name. We don't want them to be connected. You guys following? So I'm just gonna do that. And then there we go. And guess what I'm going to do with this middle line right here? Delete it. And now I've got 2 zones. Well, mine's RGB, so I need 3 zones. So I need to do it again. File, import, Eagle Drawing. Go find that original one. There it is. Ignore any errors that might pop up. Click it. Make sure power and ground are connected, but everything else is different. Okay. Delete that middle line again. Okay. Now I've got this. Now, here's the part that is redundant that I need to fix. And I have to fix it on the schematic side. How many switches do you actually need? You just need one. How many connectors do you actually need? Just one. And so what I'm going to do is I'm going to go over to the schematic, and you'll see what's happened on the schematic here. I got to go View, Sheets. And you'll see now that I have 1, 2, 3 sheets. So for sheet 1, that's my master one. I'm going to leave it alone. Sheet 2, what I'm going to go in and do is I'm going to delete every single pin because I only need 1 set of pins. So all of the pins on sheet 2 are going to go away, all of them. I'm going to go to sheet 3. I'm going to delete every single pin. Let's delete them. Okay, I'm gonna pause. All right, so here's the last sort of key step. These connectors right here, this one is my green and this one is my blue because I have my red right here. Here's pin 2 for red. And then this was supposed to be green and blue, and I told you to just leave them there. And so what we're gonna do is I'm going to go here and I'm gonna create a little net, hit escape, create a little net, hit escape, and I'm going to start naming these things. I'm going to click name. What color did I say this one was? Green. So I'm going to go GRN, green. And then this one was blue, BLU for blue. And just for good measure, to remind myself, I'm going to go here and go RED for red. That was the first one. Okay. And then all I need to do now is you see this output pin here is red. On my next sheet, what should the output pin be? Should be green. So I'm going to click on it, and I'm going to type GRN, and it's going to ask, do you want to connect this? Yeah, I want to connect this green to the green on the other sheet. I'm going to go there, and then I'm going to go here and do this one. Now this one is now blue. Oops. Got to click name again. Oh, my mouse disappeared. There it is. Name. And click blue. Oops, wrong. Missed. I can do this. I can click and type BLU. That's going to ask, do you want to connect it? Yes. So now all the sheets are connected, and when I go to my board, I'll see what my last challenge is. If I go here and click unrouted, okay, the challenge now is to fix all these routing issues. You see all the routing issues? Here's how you fix them. First, let's go ahead and go to top and bottom. Do you guys see how many polygons I have? I have a bunch of extra polygons. Delete the duplicate ones. So I'm going to right click on here, delete that polygon. Delete this one. Sorry, whoops, I should hit right click delete. Be faster. You guys follow what I'm doing right now? Or are you just messing around right there? Okay. And then I'm going to make this bigger to just cover the whole thing. So I have a single set of polygons. Okay. And then now if I look at it, I'm going to go ahead and hide these layers. Even hide the values and the place layers. How many air wires do I actually have left? I have 2 because I added green and blue. So all I have to do is wire up those things, and if I look here, on my bottom layer, I've even partially routed them. Because they are part of the template, they're already coming up. And so I just need to go in here. I'm going to need to change this back down to like 0.5 millimeter, not 20. I don't want to go in 20 millimeter chunks. And then I just need to take this and wire it up. Wire it to there and rip that up. And then go to the other one and wire it up. Okay. And then you do want to double check to make sure on the silk screen layer that everything still looks right, because it's possible something didn't quite look right. So going to T-place and T-values, but it's more than likely that if you had already done the silk screen layer that it still looks good. Oh, I see one obvious problem. See the name there 3 times? Only need it once. But that's it. Okay. So it's not that much extra work to get red, green, blue to work.